Before we start this lecture, I want you to unlearn anything that you know about the graphics card and only pay attention to the abstractions that we define in this lecture. So imagine that this is the monitor, this is the graphics card, and this is us. By us, I mean like the processor or the RAM that you have written something in the RAM and the processor is executing it. So we know that the way that the monitor works, just imagine that we want to write the character A on the monitor. And we know that the monitor or this type of monitor that we are talking about works is that it has a cable, and inside the cable it has some pins which are connected to the graphics card. One of those pins is called the VDOO, and if VDOO pin is 0 or the low voltage, the monitor wouldn't emit any light and therefore it would see black on the display. If we put the high voltage or 1, then the monitor would emit light and we would see green. So we say that black is the background color and green is the foreground color. Now, imagine that first we divide the display in some squares, and we call each one of these squares as one unit or a picture element. Now, we could get the initials of the picture as pic and el in here, and the result would be pixel. In fact, pixel is what was used to call these squares. Later, this C became X, and it would be called pixel now. So let's imagine that the graphics card first generate the byte equal to 30 in hex. Later, I say why it creates such a number. But let's just imagine that the graphics card create the value of 0011 or 0000. Well, obviously, this in binary is equivalent to 30 in hex. So the first thing that the graphics card would do would be to feed this to the monitor on the VDOO pin from here. So first, 0 would be given to the VDOO pin. Well, obviously, 0 would cause the background color to be shown or no light, therefore the result would be black. Therefore, black would be shown on the first square. Also pay attention that these borders are not real. I've just shown you these borders so that you could see them. So next, the graphics card would give this 0 on the VDOO pin. Therefore, the second square would also be black. Later, 1 would be given on the VDOO pin, and therefore, since VDOO pin is 1, the display would show the foreground color or green. So we would have green in here in the third square. Next, the next one, which is 1, therefore 1 would result in the emitting light of the display, and we would have green, so green we would have here. The next 4 are 0, so we would have 0, 0, 0, and 0 in here. Some abstractions I want to define right now. First one is that we say the monitor is scanning all the pixels, and we call the first row, the first line that the monitor is scanning as the scan line. So this is the first line of the monitor. You could see that this is in here. This is the first line of the display, the topmost. And this would be the leftmost in here. It is scanning from left to right, and we call this as the scan line. So monitor is scanning the pixels from left to right for one scan line. Also, since we have 9 pixels in here, or 9 squares, we say that our display has a horizontal resolution of 9. Obviously, the name just speaks for itself. It means we have 9 pixels in each scan line horizontally. So we say it has a horizontal resolution of 9 pixels. So the next value that the monitor would give, let me actually change my color so you could see better. The next value that the graphics card would give the monitor, just imagine it would be equal to 78 in hex, which in binary it would be 0, 1, 1, 1, 1, 0, 0, 0. So first, the value 0 would be given by the graphics card on the VDOO pin. Therefore, black would be shown on the first pixel of the second scan line. Next 1, therefore green would be shown, so you would have green on the second pixel of the second scan line. and the next we have 1, therefore we have green. Again, we have 1 green, we have 1 green, and the next 3 obviously would be zeros, therefore you would have black. Let me also remove these rows. So after that, the graphics card for the third scan line would create the value of CC in hex, and CC in hex is equal to 1100 or 1100. And first, this 1 would be given to the video pin, therefore you would have green. Then this one, and you would have green again, 2 zeros, 2 blacks, again 2 ones, 1 by 1 would be given on the video pin, you would have 2 greens, and finally we have 0 0 resulting on the black to be shown. And this would go on, and the monitor would give 5 more bytes, which would be CC again, FC, so CC would be again this one, then FC, so you could imagine that FC would be this, because this is FC is equal to 1 1 1 1 1 1 0 0. Wherever we have 1, 1 would be given to the video pin, you would have green. Wherever it is 0, you would have black on the pixels. After this, you would have CC again, and 0 0. So CC is like this one, in which, as you see, we would have these 2, and 0 0 would be all black. If we zoom out, as you see, the character A has actually been shown. So right now, you see the monitor and everything in the computer doesn't understand anything. You see, it is just processing. The monitor has some features which we could control by putting the low voltage or high voltage on the video pin. So even right now, if you wanted to design a graphic card, you would say, I need a RAM, some RAM. In fact, let me actually call you this. If we zoom in this graphic card, you would see that we need several elements. The first one would be RAM. Let me actually make my pen smaller. So the first one would be RAM. Why do we need RAM? So that we could tell the graphics card what we want to be written on the display. We know that we want to write the value of A, but we also know that computer doesn't understand anything called A. It understands zeros or ones. So A would have a number associated to it that the graphics card would know what this A means. This value would be 0x41. We say this is the ASCII value of 41, or the code point of the A. So 0x41 means we would have 01000001. So by writing this value or 41, we are telling the graphics card that we want the value of A to be shown. We also need a ROM, and that ROM has to contain what we call as the character map of the A character. What it means is that all the bytes that I told you, 30, 78, CC, CC, FC, CC, CC, and 0C, they are called the character map of the character A. Now imagine what would happen. We write a value of 41 in hex, or 0100000001 on the RAM. This value would be put on the data bus. This would select one memory cell on the ROM, on the read-only memory, which the data wouldn't be wiped out as we unplug it from the power. So first, the value 30 would be put on the output of the ROM on the data bus of the ROM, of the output of the ROM. So 30 would be given to the shift register. 30, we know, is binary, is equal to 000110000. This shift register would work in a way that first this 0 would be shown on the output. This output would go on the video pin connected to the monitor, and the monitor in here would receive this video pin and would show the background color or black as the first square or first pixel. Then it would show, it would put the next 0 on the video pin, next would be the 1 on the video pin, which would result in the third pixel to be green, and so on. After the first byte is completed, then the next byte, which is 78, would be fed to the shift register, and the same things would be done. So as the basic requirements, you see that the graphics card at least needs one RAM, one ROM, and one shift register. And you would see in every graphic card, we would have these 3 elements, these 3 most important elements. But well, in this case, since we have, or all of our display is in fact capable of showing only one character, so our RAM only needs to be one character. If you want to, even though the RAM has to be much bigger. Why? Because imagine instead of 0x41 or A, you would want to write the value of B. Well, B would have a value of 0x42 associated to it. Associated means with that value, we tell the graphics card what we want to be shown. So if we write 42 on the RAM, then you see that's the reason that we need RAM here, because we need to write, not only write to it, but we need its value to be changed. So if we write the value of 42, some other memory cell that here would be selected, and alongside it, the RAM would have 8 other bytes, which would obviously represent the value of character B. You could just imagine that if you wanted to write B, you would say, well, if this is our display, you would say, well, I want 0, 0, 0, or 1, 1, 1, 1 here, then I need 1, 1, maybe I'm looking at here, 1, 1, 1, 1, then 1, 1, maybe 1, 1, 1, 1, 1, 1, and in here this would show the value of B. So you could imagine what character or what bytes maybe would map the value of B on the monitor. So in our imaginary graphics card, we need a RAM capable of 1 byte of data or 1 memory cell. But our RAM has to be much bigger. It depends on how many characters we want to show on the display. If it is all the uppercase letters of English alphabet, then you need which are 26 numbers, and each byte is representing, well, each character needs 8 bytes to be represented by, which are these 8 bytes in here. Therefore, we say 26 by 8 is the minimum capacity of RAM that we need. We also need 1 shift register. But as I said, this was a very simple case. You see, I thought a lot about how to create this lecture. The first thing that came to my mind was that we zoom in the graphics card and we say that we write the value 41 in the RAM. This RAM would select a memory cell, and this data would be fed to the shift register, and shift register would give the values on the video pin of the monitor one by one. But then I thought, no, let me imagine another case so you would have a feel of the need, that why do we need a RAM, and a shift register on every graphics card that is created. And I think by now you completely have the intuition that why we need something, because when you understand the question, the answer to the question why, you will never forget things, and you don't need to memorize anything. So in the next lecture, we want to increase the size of our display so it is capable of showing more characters. And by now you could guess that if we want to increase our display so it is able to show more characters, well, most likely you need more RAM, right? Because one element would specify one location, the second memory cell another location, and so on. So in the next lecture, we are going to increase that. Before that, let me summarize the abstractions that we have defined in here, which are really important. The first one was pixel. The second one were the background and foreground color. It was also the horizontal resolution, which was 9 pixel. The vertical resolution, in our case, our monitor has a vertical resolution of 14 pixel, or imaginary monitor. And also we have the abstractions of line and a scan line and the concept of scanning. Another thing that I wanted to show you, I said our display is only capable of 1 character, but we see that we have a space in here. Well, if our monitor is bigger, we would use this display to be between different characters so they could be better read. But if you pay attention, this rectangle in here, which has 9 pixels wide and 14 pixels down, I guess, we say every character box has this value, or is this big, 9 times 14 pixels, and its display area is 8 by 8. So another abstraction that you found out is the character and character box. Every character is 8 by 8 pixels. Every character box is 9 by 14 characters. The horizontal resolution of our display is 9 pixels. The vertical resolution is 14. The overall resolution is 9 by 14. And we would have these scan lines that as we explained. And also another last abstractions is that we call all this that we said one character bus as one character row. We say we have one character row currently, which has 14 scan lines capable of saving one character. So different abstractions, they would understand later that why we are defining abstraction this way. I'm sorry if the lecture got a bit big, but as I said, these abstractions are really important, and it creates a base for us in the next lecture. In this way, you have the intuition of why we need a graphic card and how such a thing would be created.